Good morning students, welcome to Bindu Dhadwal chemistry lessons. Today we'll be covering types of attacking reagents and classification of organic reactions. Molecule, let it be substrate S. It is attacked by attacking reagent to form an intermediate which will later on decompose to give various products. Free radicals, electrophiles and nucleophiles. Free radical may be defined as an atom or group of atoms with an odd or unpaired electron. For example, chlorine, free radical, methyl, free radical, ethyl, free radical, phenyl, free radical and benzyl, free radical. Electrophiles, as the name suggests, electro for electron and phile means loving or attracting. So these attacking reagents have an attraction for electrons. So electrophile is an attacking reagent with love or attraction for electrons. So it will be wanting electrons only because it's either positively charged or neutral but electron deficient. So examples of positively charged electrophiles are H+, H3O positive, Cl positive, Br positive, NO2 positive, carbocation, then carbonyl carbocation. These are all positively charged electrophiles. Neutral electrophiles are BF3, AlCl3, FeCl3, SO3, SnCl4 and carbene. The electrophile in general are electron deficient species. These are therefore regarded as Lewis acids. They have a tendency to accept electrons. Electrophiles are electron seeking and attack a species which can act as a source of electron. So an electrophile will go to that carbon atom which is having electrons present on it. Contrary to electrophiles, nucleophiles, the name suggesting nucleus loving, is an attacking reagent with love or attraction for nucleus or positive center. It is therefore either negatively charged or neutral but with at least one lone pair of electron which it can easily donate. So H negative, Cl negative, Br negative, I negative, OH negative, Cn negative, alkoxide, carboxylate ion and alkyne iodine. All these are negatively charged nucleophiles. And amongst neutral nucleophiles we have water with lone pair of electrons, alcohols, ethers, ammonia, primary amines, secondary amines and tertiary amines. So these are general electron-rich species. They are regarded as Lewis bases. They have a tendency to donate pair of electrons. They are not electron-seeking. Rather, they go to a species which can accept electrons. And the various intermediates that are formed after attack of attacking reagent on substrate, there are 5 types of intermediates. We have already studied these. These are carbocations, carbanions, then free radicals, carbenes and nitrins. Let us move to the next topic, which is types of organic reactions. We can divide them into following categories: substitution reactions, addition reactions, elimination reactions, rearrangement reactions, polymerization reactions, pericyclic reactions and aromatization reactions. So first category is substitution reaction. So in these reactions, one or more atoms or groups present in organic molecule gets substituted by a suitable atom or group, which is called substituent. For example, ethyl chloride, the chlorine atom is substituted by hydroxyl group of KOH to form alcohol, and Cl comes out as KCl. So depending upon the attacking reagent, the substitution reactions can be electrophilic substitution reactions, nucleophilic substitution reactions if the attacking reagent is nucleophile, and free radical substitution reactions. In electrophilic substitution reaction, the attacking reagent is an electrophile. So, for example, positively charged chloronium ion will attack the carbon-hydrogen bond here and form a bond. As a result, chlorobenzene is formed. H will be removed as H plus ion. So, this happens in presence of Lewis acid, ferric chloride and chlorine. These two react to generate the chloronium ion. Similarly, benzene can react with nitronium ion in presence of sulfuric acid to form nitrobenzene and H plus ion. So here the attacking reagent is an electrophile. When the attacking reagent is nucleophile, the substitution reaction will be called nucleophilic substitution reaction. For example, hydroxide ion acts as a nucleophile and substitutes Br negative in the bromomethane compound. So in place of Br we get OH and bromide ion is released. So this is a nucleophilic substitution reaction. Similarly, cyanide is a nucleophile which will substitute bromide ion to form ethyl cyanide from ethyl bromide. Free radical substitution reaction. Here the attacking reagent is a free radical and these reactions are carried out either at high temperature or in presence of ultraviolet light. The reactions are chain reactions and they proceed very quickly. The reaction can be considered to occur in 3 steps. First step is chain initiation, then chain propagation and then chain termination. In the chain initiation step, the ultraviolet light will break the bond homolytically between chlorine and chlorine atoms to form chlorine free radicals. Propagation, this free radical will react with unionized methane molecule and break its bond again homolytically is a fish curved arrow or hook arrows and one electron of the bond goes to hydrogen, other to methyl. The one which with hydrogen will form HCl molecule, H and Cl free radicals combine to form HCl. Another free radical CH3 is generated. Similarly, CH3 free radical will react with unionized chlorine to form methyl chloride and another free radical is generated. So the these reactions result in propagation of the free radicals. So the reaction keeps on occurring one after the other. And when all the reactants have almost combined, last step is termination reaction where 2 free radicals combine with each other to form unionized molecules, addition reactions. These reactions occur when the substrate molecule consists of multiple bonds, either double or triple bond. So these are normally noticed in organic molecules which are unsaturated in nature. That is, they have at least one multiple bond, maybe a double or a triple bond in them. For example, when bromine is added to ethene, the double bond breaks, 2 valencies are freed, one Br will move to this carbon atom, another to the other carbon atom, and as a result dibromoethane will be formed. So alkene ultimately changes to a saturated product having a single bond. A double bond changes to a single bond. So again, these additions reactions can be classified into electrophilic addition reactions if the attacking reagent is electrophile, nucleophilic addition reactions if attacking reagent is nucleophile, and free radical addition reaction if attacking reagent is free radical. So for example, in case of electrophilic addition reaction, when hydrogen bromide is added to ethene molecule, the slow reaction takes place in which the electrons of the double bond will combine with the hydrogen of HBr molecule to form a carbocation CH2 CH3. H gets attached with these electrons. A carbocation is generated and Br negative is removed. Now, in the second step, which is a fast step, the carbocation will react with a bromide ion to form alkyl bromide. In nucleophilic addition reaction, hydrogen cyanide will break up to generate a nucleophile cyanide ion, which will cause the movement of electrons. The heterolytic bond, because oxygen is more electronegative, the electrons will move towards the oxygen atom. As a result, a positive charge will be generated here. The negatively charged cyanide comes and attaches here to form a bond between carbon and cyanide group, and the oxygen carries a negative charge. So first step results in generation of an anion. In the next step, the anion will take up the hydrogen ion to form formaldehyde cyanohydrin. Because the reaction occurs because of attack of cyanide group, it is a nucleophilic addition reaction. When attacking reagent is a free radical, then addition reactions are called free radical addition reaction. For example, addition of HBr on propene in presence of organic peroxide. Organic peroxide will decompose the oxygen-oxygen bond homolytically. As a result, two peroxide free radicals are formed. These peroxides will cause HBr molecule to break in such a way that each of the species contains one electron, alcohol, and Br free radical. Br becomes Br free radical, bromine free radical. Now, this was the chain initiation step. Then in chain propagation step, the free radical which is generated in the first step will react with alkene. One of the electron will combine with this bromine free radical to form CH2Br bond. Other electron is left on this carbon atom. So as a result, another free radical is generated. This free radical then reacts with HBr molecule. H will get attached here. So CH3, CH2, CH2Br is formed and another Br free radical is generated. So these steps come in the chain propagation step. Every time in a reaction, another free radical is generated. And in the last step, which is called the termination step, two bromine free radicals will combine with each other to form bromine molecule. So free radical addition reaction is also a chain reaction. So after substitution and addition reactions, we come to the next type of organic reactions, which are called elimination reactions. So according to the name, a small molecule will be eliminated from the substrate. In the elimination reaction, two atoms or groups either from adjacent position or from the same position get eliminated or removed, leading to the formation of multiple bond, that is double bond or a triple bond. So this is opposite to the addition reaction. In addition reaction, molecule is added. In elimination reaction, molecule is eliminated. In addition reaction, double bond gets converted to single bond. In elimination reaction, single bond changes to multiple bond. So depending upon the removal, we can classify elimination reaction into two types: beta elimination and alpha elimination reactions. In beta elimination reactions, the loss of two atoms or groups takes place from adjacent carbon atom. One group from this carbon, another group from next carbon. Adjacent carbon atom. So the atom to which the functional group is attached is the alpha carbon atom. So the functional group from alpha and a hydrogen from beta position will combine to form a molecule water, and a double bond will be formed in its place. So when an alcohol is heated in the presence of sulfuric acid, beta elimination occurs. The OH group from alpha carbon and the hydrogen from beta carbon will combine to form water, and because these are eliminated, a double bond is formed to complete the valencies and ethene is formed as a result. Similarly, dehydrohalogenation of alkyl halides with alcoholic KOH is also a beta elimination reaction. So when you react alkyl halide with alcoholic KOH, the halogen of halide will combine with the hydrogen of the beta carbon to form HBr. This will be removed and a double bond will be formed in its place. So we get an alkene over here. This HBr which is removed will react with alcoholic KOH to form KBr and water. In case of alpha elimination reactions, loss or elimination of two atoms or groups take place from the same carbon atom in the molecule. For example, dehydrogenation of primary or secondary alcohol with reduced copper at 573 Kelvin. So at 573 Kelvin, when you heat with copper, heat an alcohol with copper, the hydrogen of OH bond and hydrogen attached to the same carbon atom, these will be eliminated. A double bond will be formed here. So CH3CH double bond O. Aldehyde is formed, and along with that hydrogen is removed. Similarly, if you react a secondary alcohol, heat secondary alcohol with copper at 573 Kelvin, ketone is formed along with hydrogen. Similarly, dehydrohalogenation, one water and one halogen will be removed, resulting in formation of dichlorocarbene. This reaction is also alpha elimination reaction. Then let us come to the next category of organic reactions. These are rearrangement reactions. In these reactions, as the name suggests, there is an shift of an atom or group from a particular position in molecule or ion to another suitable position under suitable conditions to form a different structure. For example, butane 1-ol, when it is heated in the presence of an acid, water is eliminated. But when water is eliminated, the carbocation formed is a primary carbocation. The positive charge is on a carbon atom which is attached to only one carbon atom. But there will be a shift of hydride from this position to this carbocation positive charge position, so that a more stable secondary carbocation is formed. So instead of positive charge being present on a primary carbon atom, the shift will occur so as to have a positive charge on the secondary carbon atom. Secondary carbocation being more stable than primary carbocation. Then in the next step, an adjacent hydrogen is lost and a double bond is formed. So but2-ene will be formed. If had not a shift taken place, we would have expected a primary alkene. But because of the shift, because of the rearrangement, a secondary carbocation is formed and a but2-ene non-terminal alkene is formed. So because there is a rearrangement, these kinds of reactions are called rearrangement reaction. Expected product was but1-ene, had the rearrangement not taken place, but actual product is but2-ene because rearrangement takes place, hydrogen moves in such a way so as to generate a secondary carbocation instead of primary carbocation, which is because secondary carbocation is more stable. Then next category of reactions are polymerization reaction. In this process, a larger number of same or different molecules of unsaturated compounds will combine to form a bigger molecule of higher molecular mass. The small molecules which combine are called monomers, and the bigger molecules which are formed are called macromolecules of polymers. For example, ethene is the monomer. There's a double bond here. N number of ethene molecules will combine under suitable conditions. They will join with each other to form N times longer chain with CH2 unit as the repeating unit. So, because ethene group is repeated many times, the compound formed is polyethene. This is bigger in size and molecular mass than the reacting molecule. So, because monomer changes to polymer, this reaction is called polymerization reaction. Similarly, propene will polymerize to form polypropene. Vinyl cyanide will polymerize to form polyvinyl cyanide or Orlon, and tetrafluoroethylene will polymerize to form Teflon, and styrene will polymerize to form polystyrene. Vinyl chloride will polymerize to form polyvinyl chloride. All these reactions we'll take up in the next unit, hydrocarbons. Pericyclic reactions. These reactions do not involve any intermediate or solvent or catalyst, and in most of these reactions the bond breaking and bond making takes place in a single concerted step. So through a cyclic transition state which is quite unstable and changes to the product immediately. The reactions take place in alkenes or dienes and are initiated either by heat, which is called thermolysis, or light, which is called photolysis. For example, when ethene is heated with another molecule of ethene, the electrons of double bond move in between the carbon atoms to form a single bond. Similarly, electrons of this double bond will move here to form a single bond. Now, this is a transition state in which this bond is not entirely formed yet, and this has not entirely broken yet. So this is a transition state where bond is in the process of being formed, and another bond is in the process of being broken. So after some time, transition state will change into the actual product, which is a cycloalkane, in this case cyclobutane. Similarly, when buta-1,3-diene combines with ethene, again there is a shift of the unsaturated electrons of the double bond to form a cyclic transition state where 6 carbon atoms are combining with each other. These bonds are being formed, these bonds are being broken, and ultimately cyclohexene is formed of isomerization reaction. So under suitable conditions, we make a product which is an isomer of the reactant. For example, butane, when heated with aluminium chloride in presence of HCl gas at 573 Kelvin and at a pressure of 35 atmosphere, will change into isomeric isobutane or 2-methyl propane. So this reaction is called isomerization reaction because an isomer of the reactant is formed. Similarly, hexane can be changed under suitable conditions into 2-methylpentane or 3-methylpentanes, which are isomers of normal hexane. There's another category of reaction, aromatization reaction. So here what happens is a straight chain compound under suitable conditions is converted to an aromatic compound. So when alkanes with 6 or more carbon atoms are heated to about 773 Kelvin under high pressure, say 10 to 20 atmosphere, in the presence of oxides of chromium, vanadium, molybdenum supported on alumina. Then a bond is formed, then dehydrogenation occurs at this high temperature, and three double bonds in alternate positions are formed. As a result, an aromatic compound benzene is formed. So this reaction is called aromatization reaction. That's all in today's video. Thank you. Have a nice day.